Good morning everyone, welcome back to Question a Day. Today is July the 11th and we'll be answering yesterday's question on quartic equations. Today is World Population Day, which is the date that I believe we officially hit 7 billion people. Now obviously we're now surpassed that, we're now on 8 billion and a bit, but yeah, so July the 10th, I think that was about 2013, 2014, I don't remember, was when we hit 7 billion people. So this is a day in commemoration of that. And for this question, we've got a sketch of a curve. So we're going to draw some axes. Our key points here, well, we've got some roots, so we can tell the roots from these brackets. Our roots are going to be x equals 3. We're going to get a second one at x equals 3. We're going to get x minus 1, so x is equal to minus 1. And we're going to get x is equal to 2. So that's just from these 4 brackets up there, really. There's 3 brackets we can see, but there's 2 of this x minus 3. So we can add some marks here. We're going to mark off this minus 1. We're going to mark off 2, and we'll put a mark for 3. Other important bits of information is we'll probably need a y-intercept. Now we can work this out by just looking at we don't need to expand the entire thing, we just need to look at where our coefficient, so our constants go. So we've got a 1, we've got 2, and we've got a minus 3, and then another minus 3. The other thing we might want to do before we do this is also deal with this 2 minus x. So what we could do here, because we want these to be x pluses or x minuses, is we can take this factor of a half out, not a half, we can take this factor of negative 1 out and set this curve equal to negative x take 3 squared, x plus 1, and x take 2 is equal to y. And that we can use that for a little bit of extra information there. But that's going to flip our overall sign as well. So we're going to multiply these through. We're going to do 1 multiplied by minus 3. We've got a second minus 3 there, times minus 2, and this whole thing is going to be negative. And when we work this out, that's going to be 3 times 3 is 9, times 2 is 18, which gives us a y-intercept. Our y-intercept is going to be equal to 18. We can check the minuses, we get a minus, another one. So it's 4 minuses, they will make a positive. So we can mark on our y-intercept of 18 up here. Now the last bits of information that we're going to need to use are kind of our known shape of a quartic. Now because this is negative, we know that that when we put in a really big negative number, we're going to be on kind of in the negatives over here. So because 4 negatives makes a positive, because we're taking the negative of everything, so we've got a really big positive number, and then we take the negation of that, that's going to be a really big negative number. So, with all that information kind of talked through, we can also think about the general shape of one of these graphs. So I'll just add a note on that as well. A quartic, in general, kind of has this W shape. So that would be a positive quartic, and then a negative quartic would kind of look a bit like that. So that's our negative. And our other bit of information to notice is this x minus 3 here, so it's x minus 3 squared is repeated, which means our curve is going to touch it, but it's not going to go through it. So kind of like in a quadratic, if we have a repeated root, it just glances off, so it will come down and glance off the x-axis without going all the way through. The same thing's going to happen here. So we're going to start really, really negative. We're going to come up. We're going to continue to come up through this 18. Now we're going to turn around because we want to go back down through that 2 there. We know we've got 4 roots, so it has to cross here. So that's our 2. And now we're going to curve back around because we need to hit the 3. And because we've got 2 roots at that 3, it's going to look something like that. Again, we can put up probably a better plot of that in a second. But that's the general gist of what you should have there. That's the general shape of this curve. Okay, so we've got Desmos back out. GeoGebra, sorry. We've got Okay, so we've got GeoGebra back out. We've plotted this curve. This is our x minus 3 squared times x plus 1 times 2 minus x. And you can kind of see we've got the general gist of it. So our curve versus their curve. Ooh, moving the wrong thing. There we go. They're fairly similar, but that's kind of your general shape that it should be. So we're starting really, really negative, going up to the positive. We've got a turning point there. Our turning point is on a slightly different side of the x-axis. So theirs is on the left side, ours is on the right. We could establish where that is using differentiation to find where the turning points are. But for now, I call that good enough. So yeah, we could use differentiation, we could really go down and deep into it, but we'll leave that there for now. But that's everything for today. I'll see you tomorrow.